Welcome to Lesson 74, Simplifying Square Roots. Now we know square roots look like this. We've often solved them like square root of 25 is 5. So this would be nothing new, except now we're going to be working with much bigger square roots. So something like the square root of 600. Now, the square root of 600 is not a perfect square, but we can simplify it, or in other words, reduce it. Okay, so let's take for example, the Pythagorean theorem. We know that a squared plus b squared equals c squared. And what that looks like in diagram form is this. You have a right triangle, and it's a squared plus b squared, and that is equal to c squared. Now, I know that I made this side 1 unit or 1 centimeter. I also made this side 1 unit or centimeter. So when we come over here, we can solve it in our Pythagorean theorem. A squared plus b squared equals c squared, and I fill that in. 1 squared plus 1 squared equals c squared. 1 plus 1 equals 2 equals c squared, and then c equals the square root of 2, which we also knew that from restart. We also knew that from our 45, 45, 90 degree special triangle. It's a 1 to 1 to square root of 2 triangle. Okay, so let me zoom out here, and then let's scroll down right here. So I have moved this drawing right here, and I made another one, except this one is 4 times bigger. And how I knew this was 4 times bigger is right here. This is 1 centimeter, and this right here is 4. We can also count 1, 2, 3, 4. So this figure right here is 4 times bigger than this figure. Now we can set up some ratios like we've done before, and now we can set up some ratios like we've done before, so let's go ahead and do that. We're going to say 4 is to 1 as this side, which we're going to label as x, is to the square root of 2. So let's go ahead and do that. So we're going to say 4 is to 1 as x is to the square root of 2. Now, let's go ahead and do our cross multiplication, just like we normally do. So we have 1 times x, which equals 4 times the square root of 2. Now, please take notice right here. There's no sign between these. So the 4 and the square root of 2 are being multiplied. All right, so we don't really have to do anything here because right here it's a 1, and 1 times x is just x. So x equals 4 times the square root of 2. Now that makes sense. If we know that right here, if we know that that is the square root of 2, and we know that this triangle or this figure is 4 times that, we're going to say 4 times the square root of 2, right? We're going to get this. Now let's try this if we were going to do Pythagorean theorem. Let's see what we get. So we'll start with a squared plus b squared equals c squared. And we have 4 squared plus 4 squared equals c squared. And I have 16 plus 16 equals c squared. And now I have 32 equals c squared. Okay, the square root of 32 equals c. Now, let's look between. Now let's look between these. Right here we have 4 times the square root of 2, and here we have the square root of 32. Now, I'm going to tell you, both of these are correct. They don't look the same, but both are correct. So we're going to say 4 times the square root of 2 is the same thing as the square root of 32. Now, suppose that we take this square root of 32 and we make it look like, no, scratch that. Okay, restart. So how could we possibly make these two the same? Let's take a look at 32. Let's write that as a product of primes. 2 goes into 32 16 times. Now wait a minute. Right now, this 32 that we have is inside a square root. But that 32 is broken up into 16 and 2. Now, scratch that. Okay, restart. Now, how can this right here be true when they don't even look the same? Well, let's think about 32 for a second. 32, another way to write it would be something like 16. Okay, restart. Another way to write 32 is like this. Right? So suppose we do that inside the square root. So I'm just going to leave that 4 times the square root of 2 alone, and we'll just keep bringing that down. But let's take this 32 and rewrite it 16 times 2. Now you say, Mrs. Smith, why would we want to do that? How would that be helpful? Well, we do know what the square root of 16 is. And we've been doing that for a while. We do know that the square root of 16 is 4. And if the square root of 16 is 4, can we just simply remove that from inside the square root and put it out front? So we're left with 4. And then what's still left inside the square root? It's a 2. 4 still times the square root of 2. And look at that. They're the same. So it's 4 times the square root of 2 equals 4 times the square root of 2. We've got it. Now, what the actual lesson is here, and what they're trying to get at, so what the actual lesson is here, and what they're trying to get at, is whatever's inside of a square root can be written as a product or an expanded view, or we can even use prime factorization. Prime factorization, if you recall, is like this. 2 goes into 32 16 times divided by 2. 2 goes into 16 8 times. 2 goes into 8 4 times. And then we have 2 and 2. Okay? So that is prime factorization. Quick little review there. And that's how this is very, very useful to us. So here is our property for this lesson. It's the product property of the square roots. So if you have a square root with AB inside, and these two right here are being multiplied, you can actually separate them. you can actually go, well, the square root of a times the square root of b. And what this looks like with numbers is you have 2 in for a and 2 in for b. 2 times 2 equals the square root of 4, which we all know to be 2. Now take a look at this 2 right here. What do you notice about it being in here? Well, there was 2 of them in here, right here, 2 and 2, and they were being multiplied together. Now, we've seen multiplication written a different way. Like 2 squared is the same thing as 2 times 2. Now, let's think about that a little bit further. If I had the square root of 2 squared, wouldn't that just be 2? Because if we were to go, the square root of 4 equals 2. 2 times 2 is 4, and the square root of 4 is 2. So the square of something, so like a squared, is undone by a square root. Just like when you do 3 times 2 and you get 6, but if you divide 6 by 2, you get 3. Okay, so division undoes multiplication, and multiplication undoes division. So like right here, a squared is undone by the square root, or the other way around, a square root is undone by being squared. Now let's think about this. The square root of 2 times the square root of 2, using this property over here, gets us the square root of 4, which equals 2. Now take a look here. This is the same number that's in here. So what you can deduce is if you have the 2 of the same numbers inside of a square root, you can, So what you can deduce is if you have 2 of the same numbers inside of a square root, so for example, if you have 4 times 5, you can just pull these two 4's out, and it's going to be 4 times the square root of 5. Easy, simple reduction. Now, to do this the long way, you would say 4 times 4 is 16, and just like we saw up here, the square root of 16 is 4. Okay? All right, so let's practice right here with this 600 right here. Okay, so 600, well, let's break that up into something that we know. Let's do some prime factorization. Let's do that in a different color. Okay, so let's do some prime factorization, and we'll start with 600. Let's go ahead and do that. Let's divide that by 2. Then we have 300. And divide by 2 again, we're at 150. Divide by 2 again, and we're at 75. Now we're going to divide by 5. We're going to get 15. And then we're going to divide by 5 again, and we're going to have 3. Now take a look at this. We have a couple pairs in here. There's a pair of 2's and a pair of 5's. Now if we were to take those 2's, if we were to take this and write this out long ways, it would look something like this. Okay, take a little note right here. See how I put a little tail on this square root? That's going to come in handy. You might want to start getting used to writing that because that signifies that you have ended your square root. And square roots are going to start showing up in your solving for x problems, okay? Okay, so like I was saying over here, we do have some pairs. We have 2 2's and 2 5's. Now up here, when we said we had a pair, we just took them out. So let's try that here. If we take out the pair of 2's, we're going to bring that out here, 2. we're going to multiply it by 5 because we had another set of pairs, one right here. Okay, and then we're going to put 5. And what's left? So we took out this 2, and this 5, and this 5. And we're left with 2 times 3. Okay, so on the outside we have 10, and then we have times the square root of 6. So 600 reduces down to, or simplifies to, 10 times the square root of 6. Now, let's think about this another way. How could we have written 600 differently? We could have written it differently like this. 6 times 100, or the square root of 6 times the square root of 100. Okay, so that follows this property right here. We had 6 times 10, and then we broke it up into 6 times 10 right here. Now, do we know, or sorry, not 6 times 10, 6 times 100. Now, do we know what the square root of 100 is? We do. It's 10. So we would say 10 times the square root of 6. And look it, we got the same answer. Now, not all of them that you're going to be working with are going to be like this. They're not going to be this straightforward. Some will be, but not all of them. So it is good to know this method right here of solving for the prime factorization, and then finding the pairs that are inside the square root and pulling those out and multiplying them together. Okay? Okay, let's move on to example 1. All right, so they're giving us 2 of these square roots to solve. So let's start by doing prime factorization. So we'll take 216 and let's divide that by 2. So we have 2, not 2. So we have 108. Divide that by 2 and we have 54. Okay, look, we've already got a pair. So let's take 54, let's divide that by 2. 54 divided by 2 is 27. And we can divide by 3, which is 9, and then 3 and 3. Okay, so I see a couple pairs. I see this 2 and this 2, and then I see this 3 and this 3. So let's rewrite this as a product of primes inside the square root. And don't forget your little tail. So we have 2 times 2 times 2 times 3 times 3 times 3. So let's pull out our pairs. So we got 1, 2. And we'll put down a 2. And then we got our 3's, 1, 2 times 3. And we're going to leave the square root. And I'll have a 2 and a 3 left. And 2 times 3 goes inside. Okay, so what's 2 times 3 on the outside? That's 6. That's 6. And then what's 2 times 3 on the inside, which is still 6. So I have 6 times the square root of 6. Okay, and that's pretty much all that you have to do for these problems. All right, next one is 210. And 210, let's go ahead and do a prime factorization for that one as well. Okay, so let's start here. We'll do 210. We'll divide that by 2, and I have 105. Okay, well, I know that 105 is divisible by 5, which is 21, and 21 is divisible both by 3 and 7. Now, I don't see any pairs here. I see a 2, a 5, a 3, and a 7. Now, none of those are the same. And when none of them are the same, that means that this number is reduced down as low as it possibly could be. So, what's inside here is 210. So the square root of 210 remains 210. Okay, So this was example 1 found on page 498. Example 2. Example 2 is a little bit of a word problem here. Example 2 found on page 499 reads this. Instead of walking 200 yards from point A to point B, in other words, going around the corner. This is 100 yards, and this is 100 yards. So instead of walking the 200 yards it would take to get from A to B, he just cut across a field. So Arnold takes the shortcut across the field. How long is the shortcut? Okay, so this is a real simple problem of using the Pythagorean theorem. I have a squared plus b squared equals c squared. So we're going to put in 100 squared plus 100 squared equals c squared. So 100 squared is 10,000. Okay, now 10,000 plus 10,000 is 20,000, which equals c squared. So c equals the square root of 20,000. Okay, so that's kind of an unhelpful number. Do you want to go the square root of 20,000 or do you want to walk 200 yards? At this point, we don't know. So we can simplify 20,000 though. Now we could take this one and write it up as a product of primes, or we could take it apart inside. We can take 20,000 and we can divide it by 2, and then we're left with 10,000. Now, we know what the square root of 10,000 is right here from this. 10,000, the square root of that would be 100, right? So here we can say, well, we can break this up. We can have the square root of 2 times the square root of 10,000, and this is based on our product property of the square roots, this right here. Okay, so let's go ahead and apply that, which we did right here. We have the square root of 2 times the square root of 10,000. Now, what is the square root of 10,000? Well, we figured that out from our Pythagorean theorem over here, and that was 100, and we're left with the square root of 2. Okay, so that's a little bit more helpful. It's 100 times the square root of 2. Now, if you recall from our lesson on the special triangles, one of your practice problems said, what does the square root of 2 equal approximately? It was 1.41, right? So we can take 100 and multiply that by 1.4. And we get 141 yards. Okay, so that saves you about a little under 59 yards of walking if you go from A to B like this versus going across the corner like that. All right, so that's our answer to example 2. So in your book on page 499, there are a couple more of these approximations, kind of like this one right here. So let's look at them, some of them that you'll be using. Now you don't have to find this unless they specifically ask you for it. An answer like this one is perfectly acceptable. So you could say something like 6 times the square root of 6, and that is okay. But when they're asking you for an actual distance like they did in example 2, then you're going to want to use your approximation and get 144 yards. Okay? For now. All right. So here's the table. And in this table, we have square roots. So square root of 2, square root of 3, square root of 5, square root of 10. And then here's the approximate value. Square root of 2, which we had already said was 1.41. Square root of 3 is 1.73. Square root of 5 is 2.24. And the square root of 10 is 3.16. So this chart's located on page 499, and you're probably going to have to refer back to it a couple times to solve these problems moving forward on future lessons.